Find the domain of a radical function h of x equals square root of x squared minus 6x plus 8. We have an even root, and inside of a radical we have a polynomial as a radicand. So we're going to set the radicand greater or equal 0. To solve for x, first we're going to factor this polynomial. So our factorization will be x minus 2, x minus 4 greater or equal 0. We're going to make a box around this because it's going to be very important. Eventually, instead of dealing with this, it will be easy to deal with this one. We can also write as x minus 4 parentheses x minus 2 greater or equal 0. It's the same thing. So now to find the boundary points, we're going to set this inequality as equal 0 sign and solve for x. So we get x minus 2, x minus 4 equals 0. So x minus 2 equals 0 or x minus 4 equals 0. So our boundary points are x equals 2 or x equals 4. We're going to place these boundary points on a number line. So this is my number line. And my boundary points are 2 and 4 right here. Now we're going to choose the test points. So the test point from negative infinity to 2, I'm going to choose 0. So the value I choose here is 0. From this interval 2 to 4, I'm going to choose my test point as 3. So this test point is 3. And from this part 4 to infinity, I'm going to choose the test point 5. So my test point is 5. Now I'm going to check this test point and see I should shade this region or I don't shade this region. So test point x equals 0, I'm going to plug, I get this. And now you don't have to simplify or find answer. You just times this. So as a signs, so negatives times negative, it's positive sign. Positive greater or equal 0. This is a true statement. That means this region you shade. So when you shade, your shading will be from here up to here. Now let's check the next test point. 3 minus 4, 3 minus 2 greater or equal 0. This is negative, this is positive. Negatives times positive equals negative greater or equal 0. This is a false statement. So you leave this region alone. You don't do anything with it. Now my next test point is x equals 5. When we plug it in, we get x 5 minus 4, 5 minus 2. Let's check it. This one is positive, this one is positive. Positives times positive is positive. Positive greater or equal 0. This is true. And when it's true, you shade this region. So when you shade it, what you ended up getting is from 4 to infinity. Now we need to know what happens at the boundary points. Are we going to have a parenthesis or bracket? So when you check the boundary points, and if it's true, then you will have bracket. If it's false, then you will have parentheses. So let's put this statement here in to just give us ourselves a little clue that if you have true, then you will have bracket. If it's false, then you will have parentheses. Okay, let's plot in the points and let's see 2 minus 4 and 2 minus 2. Now 0 times any number 0, 0 greater or equal 0, that is true. And that means you will have a bracket at that point. So when you draw a bracket, your bracket has to face the shading part. So this is your bracket. Now let's go for the next one. 4 minus 4 and 4 minus 2. greater equals 0. When we check, we get 0 times any number. That is just 0, and 0 greater equals 0. This is true as well. So we are going to have a bracket at that particular boundary, point x equals 4. So my bracket is going to face the shading part. So my domain for this particular function is from negative infinity to 2 union 4 to infinity. Negative infinity to 2 closed interval union 4 to infinity. And for sure, if you look at the graph, your domain, the graph, you can say your domain is from negative infinity to 2 and from 4 to infinity. So hope this will help you.